Okay, we are going to continue on with chapter 2-3. There's a lot in chapter 2-3. Today we're going to focus on Descartes' rule of signs as well as the rational root theorem. The rational roots theorem. Now, the remainder theorem says that if I take any function and divide it by x minus k, if I do synthetic division, my remainder r is going to be f at k. We learned that yesterday. In order to be a factor, we learned that your remainder has to be what? If you are a factor, your remainder must be 0 when you do synthetic division, correct? We learned that as well. Now, the next thing we're going to learn, which is today, this is new, is called the rational zero, bless you, the rational zero test. What this says is given any polynomial in the world, if you take its p-value, which we know to be a constant, and you divide it by the q-value, which we know to be the leading coefficient, then that will give you a list of all the possible rational zeros that you can have in the world. Okay, now, you always are going to do plus or minus. And the reason why you're going to do plus or minus is because you always want the positive aspect and the negative aspect of it. Because two negatives make a positive, right? We all get that. So that's why you have to have a plus or minus. And we're going to go over that. Now, when we are talking about the type of roots that you have the real number system as the entire x-axis, correct? Inside the real numbers are going to be rational numbers and irrational numbers. P over Q is going to give me this box right here. P divided by Q gives me the rational box. The irrational box is found by using the quadratic formula or by factoring. And similarly, the imaginary numbers are also found the same way. They're also found the same way. So if I have irrational roots, the way I'm going to get those irrational roots is going to be x equals negative b plus or minus square root of b squared minus 4ac all over 2a. How many of you remember that song? You guys did a ton of the quadratic formula last year. A ton. Okay, you should remember that. And we're going to go over a little bit of that later on this week or next week as well. Now, imaginary numbers can only be found by doing factoring and setting each one equal to 0 and solving. For example, the square root of negative 9 is going to be plus or minus 3i. Yes. The square root of negative 4 is plus or minus 2i. Yes. That's why you have to have a positive and a negative. Okay. Now, the next thing is Descartes' rule of signs. Descartes' rule of signs tells us how many positive roots we're going to potentially have and how many negative possible roots we're going to potentially have. Then it tells us how many are left to be imaginary because the grand total will be the highest exponent. Now, how do I find my number of positive roots, I should say? To find the number of positive roots, we're going to count the number of sign changes in f of x, which is the original polynomial. Okay? Then, let's say my number of sign changes were n is equal to my number of sign changes, and that's 8. Then it says that you're going to subtract 2 from the number of sign changes, and this is the possible positive number of roots that you're going to have. So if I take 8 and subtract 2 from that, how many do I have? 8 take away 2? Now subtract 2 again from 6, and what does that give me? 4. Now take and subtract 2 again. That gives me 2, and now subtract 2 again, and that gives me 0. So if I have 8 sign changes in my polynomial, I'm going to have 8, 6, 4, 2, or 0 positive roots. I can't have 1, I can't have 3, I can't have 5, I can't have any of the odd numbers. Do y'all understand that? However, if n is number of sign changes is 5, 5 take away 2 is, take away 2 is, take away 2 is, negative 1. If you're counting things, can you count negative 1? No. So that means you're either going to be at 0 or above. So if I have the number of sign changes is 5, that means I'm going to have 5, 3, or 1. Do we understand that? 5, 3, or 1. We all good? Now, Same thing is true to find the negative roots. However, the negative roots are going to be from counting the sign changes in f at negative x or p at negative x. Same thing. You're still going to subtract 2. Now, here's what I need your brain to understand. When you do f at negative x, okay, the only powers that change coefficient signs are going to be odd powers. Odd powers change sign. And we're going to do an example of that in just a minute. Okay, the next thing I want to talk about is b squared minus 4ac. Where does b squared minus 4ac come from? Quadratic formula, right? B squared minus 4ac comes from the quadratic formula. Can we see this right here? B squared minus 4ac is underneath the square root of the quadratic formula, yes? And what this says is you are simply going to do b squared minus 4ac and you're going to say, is it greater than, less than, or equal to 0? Is it greater than, less than, or equal to 0? If it is greater than 0, then you're going to have 2 real roots. If it's a perfect square, that means it's rational. If it's less than 0, then that means you're going to have 2 imaginary roots, because can you take the square root of a negative number and be in the real number system? No, which is why it's going to be imaginary. And then if it is equal to 0, that means you're going to have a double root. Okay? Now, the very first thing we're going to do is we're going to do, you probably are going to take this example that's in your notes right now, and you're going to probably have to do it on a separate sheet of paper because you don't have enough room. This is exactly like problems 1, 2, 3, and 4 tonight for homework. This problem that I'm doing right now is exactly like problems 1 through 4. This is actually number 2. This is exactly how you do problems 1 through 4. Are you ready? Now, it says step 1, verify that the given factors by performing synthetic division. So I want you to show me that those two numbers, which are x minus 5 and x plus 4, are factors of the original polynomial f of x. Do we all understand that? In order for them to be factors, when you do synthetic division, what must they be? What must the remainder be? 0. Do we all understand that? So what we're going to do is we're going to go ahead and we're going to take these factors, which is x minus 5 is equal to 0 and x plus 4 is equal to 0. And we're going to figure out what we're going to put in our half box. So I'm going to add 5 to both sides to give x equals 5. And I'm going to subtract 4 to give x equals negative 4. Do we see that? Yay or nay? We good? Okay, now I need to do synthetic division at each of those values. So we're going to do synthetic division at 5 first. So I put 5 in the half box. Did we see that? We're going to put 5 in the half box. Now, I need to pull all of the coefficients off of my polynomial. So that's 1x to the 4th, negative 4x cubed, negative 15x squared, 58x, and negative 40. And yesterday, I taught you to always look at the highest exponent, which is 4, and then to count down and check that you did not miss any placeholders. 4, 3, 2, 1, 0. Did I miss any? I did not, so now I'm going to do synthetic division. So I go ahead and I draw a line, and I drop down the 1. Multiply the diagonal, that gives me a 5. Add vertically, 5 and negative 4 is 1. 1 times 5 is 5. This gives me a negative 10. Times 5 gives me negative 50. Plus 58 gives me an 8. And 8 times 5 gives me a 40. 40 and negative 40 give you 0. What did I just verify? That this is indeed a factor. Do we understand that? Now, since I proved that and I did synthetic division, what happens to the degree of this polynomial? It goes down from degree 4 down to degree 3. Do we all understand that? Now, the wonderful thing about synthetic division is if I know I have more than one root, I can go right from here and I can do another root. So I'm going to go and put a half box here. And I'm going to put negative 4 inside that half box. Do we see that? And I'm going to go straight from these values that I used previously. Do we understand yay or nay? So I drop down the 1. 1 times -4 is going to be -4. Plus 1 gives you a -3. -3 times -4 gives you a 12. Minus 10 is 2 times -4 is -8. Plus 8 gives you a 0. What did I just prove now? That this is also a factor. So I verified that they're factors by doing synthetic division. What's number 2 say I need to do? Find the remaining factors. So once I've done synthetic division once, it dropped it down to degree 3. Now I did synthetic division again, so what is that going to drop that down to? A degree 2. Do we see that, yes or no? Now, what is the polynomial that remains that's degree 2 now? What is this? X squared minus 3x plus 2. And we're going to set that equal to 0. The reason why we're going to set that equal to 0 is because we actually want to find the factors of this. So I need to factor this into 2 binomials if at all possible. So how do I factor this into 2 binomials?
-1,
That's going to be an x and an x. -1, -2 is equal to 0. So my remaining roots are going to be 1 and 2. So did I find the remaining factors? Yes, I did. So then number 3, it says to write the polynomial in its most factored form. So how do I write this in its factored form? Well, I'm going to simply say, here's a factor, here's a factor, here's a factor, and here's a factor. So I'm going to multiply them all together. So that's x minus 5, x plus 4, x minus 1, and x minus 2. Then it says to list all of your zeros. Well, my zeros are all right here. My zeros are right here. I have them, I just need to organize them. So x is equal to 5, -4, +1, and +2. Did we see that, yes or no? And then it says to verify it graphically. When in doubt, graph it out, right? Do we all understand what I just did up there? This is how you're going to do problems 1 through 4. Okay? Now, whenever we go to the next part of our homework and we turn the page, the next part of the homework is asking you to find your P over Q values, which is the rational zero test. The rational zero test is going to be the test that tells us all the possible zeros that we can have for that polynomial that are on our rational list. Okay? So the very first thing you're going to do is you're going to do your P value. Your P value is known as your constant. And what is your constant term in this problem? 3. Now, can anybody tell me all the factors of 3? Yep. Now, I want you to put a plus or minus at the very beginning of your list, because we have to include the positive aspects and the negative aspects of this. So I'm going to have plus or minus 1 and 3. Does that make sense, yes or no? Now, we're going to divide all of those values by our Q, which our Q is our leading coefficient. So what's our leading coefficient? 2x cubed, so it's just 2. And what are all the factors of 2? Again, keep the plus or minus 1 and the 2. Now we want to actually do our P divided by Q list. So what we're going to do is I'm going to put a plus or minus out at the very beginning. Now I'm going to take all of my x values or my P values and divide them by 1. So what is 1 divided by 1? What's 3 divided by 1? So I've done that one. So now I'm going to go ahead and divide them all by 2. What is 1 divided by 2? What is 3 divided by 2?
3/2.
3 over 2. This is the complete list of P over Q values. Now, what I want you to do is to find the largest possible P over Q value in that list. What's the largest number in there? 3. Now, what this means is I want to find my window size that if I would be graphing, that I would have to include all those possible zeros. My biggest number is 3, so I'm going to go 1 unit to the right of the 3, which makes it a 4. And then what's the smallest number up there? Nope. -3. So then we're going to go 1 unit to the left. So if I have a window range of my x values going from -4 to +4, I will then see every possible rational zero that will cross the x-axis on this polynomial. Do we understand that? This right here is how you are going to do problems 5 and 6. You do your P, you do your Q, you do your P divided by Q, and then you do your window size. Do we understand that, yes or no? Okay, perfect. Now, the next thing we're going to do is we're going to talk about Descartes. Descartes tells us how many positive roots we're going to have, how many negative roots we're going to have, and how many imaginary roots we're going to have, and then how many total. So let's first find out how many total is this thing supposed to have. 3. So whenever I do this, I know I have to have a total of 3 roots at least. Do we all understand that? Of those 3 roots, I want to know how many of them are positive, and how many of them are negative, and how many of them are imaginary. Now here's what I need your brain to understand. The imaginary column list will always be an even number. Because if I have the square root of -4, that's either positive 2i or it is negative 2i. I can't ignore that because within the quadratic formula, it says plus or minus the square root of. Do we all understand that? And the only way you can find imaginary roots is by doing factoring or by the quadratic formula, which is why the plus or minus concept must be there, which is why you have to always have an even number of imaginary roots. Okay? Now, with that being said, we want to find the positive roots, the number of positive roots. Now, when we talked about Descartes' rule earlier, we said that the way you're going to find the number of positive roots is by counting the number of sign changes in the original function. So if I look at my original function here, I have a positive x cubed going to a positive 3x. Did my sign change? Nope. I have a positive 3x squared going to a negative 8x. Did my sign change? So there's one sign change. Then I go from a negative 8x to a positive 3. Did my sign change? There's another sign change. To make that 2. This means that n is equal to 2. Now remember, whenever I did this, I said that you're going to then subtract what? How many units off of it? 2 units. So I can have 2 or what? What's 2 take away 2? 0. So my positive root options are 2 positive roots or 0 positive roots. Do we understand that? Both of them are possibilities. And the reason why n is 2 is because I found 2 sign changes. But then you always have to do n minus 2 to obtain the other number, which is 0. You always have to do n minus 2 to obtain the other numbers down to 1 or 0. Do you all understand? It's going to take practice. It's not fun, but we're going to keep practicing it, okay? Now, the next thing is going to be doing the negative roots. The negative roots are found by counting the sign changes in what? F at negative x. Now, when you're doing f at negative x, what that actually means is you're replacing x with negative x. So, whenever you do that, what is a negative x times a negative x times a negative x? A negative x. So this becomes a negative 2x cubed. Now, what happens whenever I take negative x times negative x? So that makes that a positive 3x squared. And what's a negative 8 times a negative x? Positive 8. And the plus 3 hangs out. Now, do you remember whenever I talked about Descartes' rule of signs and I said when you do f at negative x, only the odd power changes signs? Remember I said that? So with that being said, which ones change signs? Well, the ones that change sign was going to be x cubed. 2x cubed changed to negative 2x cubed. X to the first changed from being minus 8x to being positive 8x. Do we see that? So only the odd-powered exponents change the sign in front of their coefficients. With that being said, how many sign changes do I have? I go from a negative to a positive, so there's 1. A positive to a positive, did that change sign? No, a positive to a positive did not change sign. So that means I'm going to have at least n equaling 1, which means I know I have at least one sign change, and I have to pair it with both the 1 or the 2 or the 0. Because 1 can go with 2 and 1 can go with 0 for my positive options. Now, with that being said, can I subtract 2 from 1? No, because that's not a number that we can get to start counting. If I say, hey, how many of those do you have in your hand? You don't say -1, do you? Does that make sense? So that's why you have to do at least 1. Now, with that being said, I still have to have a grand total of 3 every time. So if I have 2 positive and 1 negative, how many are left to be imaginary? 0. If I have 0 positive and 1 negative, how many are left to be imaginary? 2. And the beautiful thing about this is I can now graph it out to determine if what I did is correct. So what I'm going to do is I'm going to grab this lovely little graph. And when you graph this thing, that is the function that you have. Do we see that? Now my question is my window size, whenever I did P over Q, said I needed to be from -4 to +4, right? Do you remember that? This is from -10 to +10. So does this mean I can see all my possible rational roots? I can see all of them. It's never going to be outside of -4 to +4. Okay? It's never going to cross anything from -4 to +4. That's all inside there. Now, how many negative roots do you see there?
1.
How many positive?
2.
So if we go back to what we know, that means that this right here is my only option. I better find 2 positive roots and 1 negative root whenever I do my synthetic division. Does that make sense? This is how you're going to do problems 7 and 8. That is like problems 7 and 8. Now, with that being said, the next thing we want to talk about, I'm going to do another one of these Descartes, another P over Q. So let's try this one more time. My p-value, what is p in this example? P is your constant. So what is my constant? 4. I do not need the negative because I'm going to automatically do plus or minus. And what are all the factors of 4?
1, 4, 2, 2.
1, 2, and 4. Do we all agree with that? Yes or no? We're going to take that and divide it by my Q. What is Q? Q is your leading coefficient, and what is your leading coefficient here?
3.
It's 3, so that's going to be plus or minus. What are all the factors of 3?
1, 3.
1 and 3. So now I need my P over Q list. So my P over Q list, I'm going to do plus or minus. Now I'm going to take all of my P values and I'm going to divide them by 1. So what are all my P values divided by 1? 1 divided by 1 is 1, 2 divided by 1 is 2, 4 divided by 1 is 4. Now go ahead and do this all by the 3's. So that's going to be 1 divided by 3, which is 1/3, 2 divided by 3, which is 2/3, and 4 divided by 3, which is 4/3. Yes?
Yep.
Now, I want you to highlight the plus and minus and the biggest number, which is 4. And I want you to add 1 unit to that, and that will give you your window size. So I'm going to be from what to what? -5 to +5. Do we all understand that? All of my rational roots will be from -5 to +5. I do not have to go outside that. If my biggest number was 24, then I'd be from -25 to +25. Do we all understand that? Yes? Okay, now, same function, but this time we're going to go ahead and do my Descartes rule of signs. So I need to do my positive roots. My positive roots, I'm going to count the sign changes in what? I'm going to count the sign changes in what? The original or f at negative x? Which one? The original. So a positive 3 to a negative 5, there's one sign change. A negative 5 to a positive 6, there's two sign changes. A positive 6 to a negative 4 is another sign change. Do we all understand that there are three sign changes? Meaning n is equal to 3. So my number of roots are going to be 3. Or 3 take away 2 is? 1. Do I subtract again? No, because that's going to make me into negative 1. So that can't be a negative 1. Do we all understand that? So now I need to do my negative roots. My negative root says that I have to do f at negative x. What powers change my coefficient sign?
3 and 6.
Tell me even or odd. Odd powers change. So the 3x cubed changes to negative 3x cubed. Negative 5x squared, does it change or does it stay? It stays. The plus 6x, does it change or stay? It changes to minus 6x, and the minus 4 stays exactly the way it is. So now what am I going to do? I'm going to count the sign changes. A negative 3 to a negative 5, nothing. Negative 5 to negative 6, nothing. Negative 6 to negative 4, nothing. So what does that mean? How many negative zeros am I going to have? I'm not going to have any. Do we all understand that? I will have none. Now, what does this mean for my nice little chart? I have positive roots, negative roots, imaginary roots, and a total number of roots. Do we all understand that? How many total roots should this polynomial have? It's going to have as many roots as I have highest degree. So I better have at least 3 roots. Okay? Well, my positive outcomes are 3 or 1. But my negative roots are always 0. Do we understand that? So how many are left to be imaginary for my first outcome? 0. How many are left to be imaginary on my second outcome? 2. Now, what we're going to do is we're going to graph this to determine which one of those is our option. So if I take this and I graph this function, here is going to be my function that I have. My window that we want for our rational roots is from negative 5 to positive 5. Am I in my window? Yeah, because it's from negative 10 to positive 10. How many times does it cross the x-axis? Once. And is that a positive root or a negative root? It's a positive root. What does that imply about the other 2 roots? They have to be imaginary, so this right here is my option. Do we understand Descartes' rule of signs? Does that make sense? Okay? All right, now, the next one that we're going to talk about is the discriminant. The discriminant is from that lovely little quadratic formula. So if it's from the quadratic formula, it's from this part right here. Do we all understand that? So here's my quadratic formula, and what we want is going to be the b squared minus 4ac. Do we see that, yes or no? So what I'm simply going to do is I'm going to take this function, which is negative 4x squared plus 4x equals 5, and I'm going to make it set it equal to 0. So that's negative 4x squared plus 4x minus 5 is equal to 0. Yes? What is a? If I were to use the quadratic formula, what would a be in this formula, in this problem? A is going to be what's attached to the x squared term. What is b? Positive 4 is what is attached to the x term. And what is c? It is your constant, which is negative 5. And what we're going to simply do is we're just going to do b squared minus 4ac. So that's b squared, which is going to be 4 squared, minus 4 times a, which is negative 4, times c, which is negative 5. 4 squared is 16. How many negatives do you see there? How many negatives do you see there? 3 negatives, which means the outcome will be negative. 5 times 4 is 20, times 4 is 80. 16 minus 80 is going to be a negative 64. Now here's my question for you. What is negative 64 compared to 0? Less than, greater than, or equal to it? this is less than 0, which would mean I'm taking the square root of a negative number. So what type of root would I have? I will have 2 imaginary roots. And this is just like problems 9 and 10, 9 through 12. Now, if my value would be, let's say, 25, I would have 2 rational roots. But if it was, let's say, 34, 34 is not a perfect square, so that would mean I'd have 2 irrational roots. The reason why this is rational is because 25 is a perfect square. And here's what your brain needs to do. Simply try to take the square root of them. Well, you can't take the square root of 34, so that means it's irrational. Can you take the square root of 25? Yes, so that means it's rational. Do we understand that, yes or no? So in your head, compare them to 0, and then always do the square roots, okay? If I have 0, then that means I have a double root, okay? All right, with that being said, that is going to bring us to our last type of example, and this right here is going to be literally problems 13 and 14. This is just like 13 and 14. Now, what I want you to do is P over Q, then do Descartes, then graph it to eliminate, and then perform synthetic division. So if we were to do P over Q, let's do number 1, P over Q. What is my P value? Yep. So what are all the factors of 16? 1 and 16, 2 and 8, 4 times 4. Yes? Do we all see that? What is my Q? Q is going to be 3. I don't need the negative. Factors of 3 are plus or minus 1 and 3. Would you agree with me? So my actual P over Q values are going to be all of my P's divided by 1. So that's plus or minus 1, 2, 4, 8, and 16. Did you see how I put them in numerical order then? Now I'm going to divide all of those numbers by 3. So that's 1/3, 2/3, 4/3, 8/3, and 16/3. If the number would repeat, you do not have to add it twice. Now, what number do I want to pick out of there? I want to highlight the plus or minus, and what other number?
16.
The 16. And that's going to help me get my window size. So my window size is going to be what? Negative 17 to 17. If I do 16 and 16's root, I'm not going to be able to tell it. So I have to go 1 unit over so I can see that pixel. Does that make sense? On the calculator. Okay, so I've done number 1. What does number 2 want us to do? Number 2 wants us to do Descartes. So Descartes says that I'm going to find my positive roots. So my positive roots are going to be, I have a negative to a positive, there's 1. A positive to a negative, there's 2. A negative to a positive, there's 3. So I'm going to have 3 or what? 1. Do we understand that? Then I'm going to do my negative roots. And now I'm only going to change the signs of which powers? The odd powers. So my f at negative x is going to become a positive 3x cubed. I'm going to keep the positive 20x squared, change that to plus 36x, and then keep the positive 16. How many sign changes do I have there? 0. So now I'm going to go ahead and do plus, minus, imaginary, and total. So my positive is going to be 3 or 1. My negative is 0 both times. And I have to have how many total roots in this polynomial? 3 both times. So how many does that leave for my imaginary? 0 and then 2 in the second batch. Do we all understand that I've just done step 1 and step 2? Step 3 says to graph it. And I'm going to run out of time today. The bell's about to ring. So I'm going to pass out today's homework. Tomorrow we're not going to move on. We're just going to be doing homework and answering questions. So please make sure you try as much of this as you possibly can so that you know what you're doing. Tomorrow we're going to be with questions, and we will go over anything you don't understand. Yes? Okay.